2017 past paper, organic reactions. All right, now we're going to be looking at this question, guys. We're still going to be using our summary. Can you see our summary on the left hand side? That is our summary, and then here on the right hand side we have got the questions, right? So we're going to be answering the questions whilst looking at the summary. Okay, in that way I'll be showing you how the summary works. It's very important for you to know how the summary works, you understand, to memorize this summary, know the summary by heart, you understand. Okay, now just like the previous lessons, okay, we're going to be using our summary. Now let's get to the questions without a waste of time. Consider the reactions represented in the flow diagram below. You can see that there is a haloalkane because of the presence of the bromine atom. It's a haloalkane, right? The haloalkane undergoes reaction 1 to produce or form the alcohol. What alcohol is that? Is alcohol A. From alcohol A, now we're going to add the concentrated sulfuric acid to form compound B. And we can see that that haloalkane undergoes reaction 2 to form an alkene. Okay, you're just looking at the arrows here. The arrows are your direction, guys, right? The arrows are your directions. It's very important to note that down. Now, compound B, which is an alkene, undergoes reaction 3 to form another haloalkane atom. But something strange. There's something strange about this haloalkane. Can you see that the haloalkane that is formed here, how many bromine atoms are here? There are 2 bromine atoms. That's strange, right? So it means, oh, 2 bromine atoms. You should be noting it down that, this has to be bromine water. So reaction 3 is bromine water that was added here. All right? It's very important to note that down. Now, we're going to be saying triple S Su the USA. The triple S Su USA is going to help us answer some of the questions. Usually the first questions, okay? That will be question 4.1.1. Can you see the type of reaction represented by reaction 1? The type of reaction represented by reaction 1, and it's 1 mark, okay? Let's look at reaction 1. We are moving from a haloalkane. We have said that this is a haloalkane here because of the presence of a Br atom. It's a haloalkane, okay? So I've written it up there. It's a haloalkane. So from a haloalkane to an alcohol, look at your summary, guys. Your summary is going to help you. From a haloalkane to an alcohol. So it is substitution. That is the reaction that is happening. That is the type of reaction. But what type of substitution is that? It's going to be hydrolysis. Remember, how did you determine that this is substitution? Remember, my haloalkane here is saturated. Haloalkane is saturated. So this compound is saturated, okay? It is saturated. How about the alcohol? The alcohol also is saturated. So from saturated to saturated, look at the triple S to USA. It is going to be substitution. Going to be substitution there. So my answer there is substitution. So it is substitution because of the triple S. Remember, from saturated to saturated, we're going to form a substitution. So that is your 1 mark there. We have our 1 mark there. Now let's go to 4.1.2. Name or the formula of the inorganic reactant needed for reaction 1. So the most important word there is inorganic reactant. Guys, the word inorganic means that between carbon and the hydrogen atom, one of those 2 atoms is not present, it's not there. And remember that for a compound to be organic, we must have a carbon atom and a hydrogen atom. So we must have a carbon atom and a hydrogen atom. But for it to be inorganic, between hydrogen and carbon, between those 2 atoms, one of them is not there. It's not present, right? So the inorganic reactant needed for reaction 1 is going to be my dilute sodium hydroxide. Guys, you're just looking at the memo here. Go to the exam room knowing that you've got the memo. You go to the exam room knowing that you have mastered organic chemistry. You go to the exam room knowing that you're going to collect all the marks on organic chemistry reactions. Can you see? This summary here is your memorandum. So I don't want any student to struggle with this. Alright, I don't want any students to struggle with this. So now we're moving from a haloalkane to an alcohol. But now what is the inorganic reagent that is needed? It is the dilute sodium hydroxide. We need to add that dilute sodium hydroxide, right? Or the dilute strong base, you can just say that. But now the name of the formula, I'm just going to write the formula, guys. Sodium hydroxide. That is my formula. So that is your 1 mark there. Easy, guys. You're just looking at the memo there. Hope you're enjoying this. Enjoy organic chemistry. Get that distinction. Hey, let's move to 4.1.3. The type of alcohol. Is it a primary alcohol? Is it a secondary alcohol? Is it a tertiary alcohol? We want to know of which alcohol A is an example. Now, alcohol A, we need to know, is it a primary alcohol, secondary alcohol, or a tertiary alcohol? For an alcohol to be a primary alcohol, it means the carbon that is carrying the OH group or the hydroxyl group must be bonded to one other carbon atom. That is a primary alcohol. Okay, so let's look at alcohol A. How are we going to determine that this is a primary alcohol or a secondary alcohol or a tertiary alcohol? My answer is that it's a tertiary alcohol. Ask me why. Let me show you how this is determined. Okay, you're going to determine this by following these steps. Okay, where did you start, guys? Look at the starting point. Look at what you were given. We're given the haloalkane. Look at the bromine atom. Look at the bromine. The bromine atom is in the second carbon. Okay, it's in the second carbon. For me to move from a haloalkane to an alcohol, it means I'm going to add the dilute sodium hydroxide together with the mild heat, right? For me to form an alcohol. Let's create that reaction. I want to show you something. 4.1.3, I'm going to write it here on the left hand side. Okay, on the left hand side. Where are we starting from, guys? We're starting from the haloalkane. Let's start from that haloalkane. Then we're going to add the sodium hydroxide. I want to show you something here. So that is my haloalkane that I'm having. I'm having my haloalkane. It has 4 carbons, okay? But the bromine atom is in the second carbon. What are we adding for us to produce that alcohol? We know that we're supposed to add the dilute sodium hydroxide, all right? So dilute sodium hydroxide is going to be added there. So I'm just going to say plus the dilute sodium hydroxide. And what are we producing there? We know that we're producing an alcohol. But what is going to be my alcohol? My alcohol, guys, this is how we're going to form our alcohol. This is very interesting. Look at this, right? Look at this wisely. Okay, remember it's substitution. The reaction that is happening is substitution. Look at question 4.1.1. It's substitution, but we're substituting what with what? We're substituting the Br atom, which is the bromine atom, with the OH atom, with the OH, all right, with the OH. Okay, look at this. This Br atom, okay, is going to be substituted with the OH. Okay, the Br atom is going to be substituted with the OH. So it means we're going to form there, instead of having the Br, we're going to have the OH. Now let's write that, guys. Let's write that. So instead of having the Br atom, we're now going to have the OH. Okay, can you see I'm writing the OH there? All right, then, so we have substituted the Br with the OH. But you may ask yourself now, guys, where did the Br go? Because we can't lose any atom. We cannot lose atoms, guys. We can't lose them. So when we remove them or when we substitute them, they have to go somewhere. It's either they are going to go to the reactants or they are going to go to the products. But where did the Br go? Obviously, the Br must go to the products. Okay? The Br was substituted with the OH. So instead of having the Br in the second carbon, we're now going to have the OH. But where did the Br go? We know and understand that the Br, I'm going to use a green color. Should I use a green color? Yes, I'm going to use a green color. The Br atom, this Br that I'm indicating in green here, it went, guys. It traveled and it had to be bonded with the sodium. So what are we going to form? We're going to form sodium bromide. That's what we're going to form, sodium bromide. So we're going to say plus here, sodium bromide. That's what we're going to have, sodium bromide. But now the question says, is it a primary alcohol, a secondary alcohol, or a tertiary alcohol? We said for a compound to be a tertiary alcohol, it means the carbon that is carrying the OH group must be bonded to 3 other carbon atoms. Okay, which compound is carrying the OH? Let's look at our product. We're looking at this product here, which is the alcohol that we have formed. Okay, this product here, that is the OH. This carbon that is carrying the OH is very special. We are going to ask ourselves that, is it a tertiary alcohol, a secondary alcohol, or what? I'm going to use pink, guys. I'm going to use pink to show that this carbon that is carrying the OH is bonded to which carbon? Can you see? The carbon that is carrying the OH is bonded to carbon number 1. Okay, I'm going to use the pink color. Then it's also bonded to carbon number 2. It's also bonded to carbon number 3. Can you see, guys? So this carbon here that is carrying the OH, that is carrying the red guy, okay, that is carrying the red guy here, is bonded to how many carbon atoms? 1, 2, and 3. So if it's bonded to 3 other carbon atoms, then we're going to say, oh, okay, it is a tertiary alcohol. Therefore, the answer is a tertiary alcohol. But how about a secondary alcohol? Let me show you an example of a secondary alcohol. Or let me start with the primary alcohol. This is a primary alcohol. So I'm giving an example here. This is EG. Primary alcohol looks something like this. 1, 2, okay. The carbon that is carrying the OH is bonded to how many carbons? I'm going to show this in blue. Is bonded to only 1 carbon atom. Can you see? Our special guy is the one that is carrying the carbon atom. This carbon atom here is carrying the OH. So this carbon that is carrying the OH is bonded to how many carbon atoms? Only 1. Okay, this is the first example, right? Let's go to example 2. So this is the first example, EG1. Let's go to EG2. EG2, okay? EG2. And here I'm going to show you how the secondary alcohol looks like. This is the secondary alcohol. It looks like something like this, okay? 1, 2. This is my secondary alcohol. It's my secondary alcohol because the carbon that is carrying the OH, look at this carbon, the middle carbon. It's carrying the OH. Can you see? It's bonded to the OH. So it means, oh, okay, this carbon is bonded, actually bonded to carbon number 1 and carbon number 2. Okay, 2 other carbon atoms. It's bonded to 2 other carbon atoms. So hence, it's a secondary alcohol. But now let's go back to the question. Let me erase this. We have said that is a tertiary alcohol because the carbon that is carrying the OH is bonded to 3 other carbon atoms. Okay. So now, yes, so it's a tertiary alcohol. You're going to underline the tertiary, and then you're going to get the mark. So my answer there is a tertiary alcohol. Okay, now let's move on to question. Let's move on to question 4.1.4. Question 4.1.4, guys. The type of reaction represented by reaction 2. Whenever they say the type of reaction, you have to refer to the triple S SU USA. Very important, the triple S SU USA. Look at reaction 2. We are only focusing on reaction 2, right? Look at reaction 2 here. Reaction 2, we are moving from a saturated, which is the haloalkane. It's saturated. How about an alkene? We know that an alkene has the double bond. Remember, if a compound has a double bond or a triple bond, it is unsaturated. An alkene, which is compound B, we know that it is unsaturated. So we're going to indicate there that it is unsaturated. So from saturated to unsaturated, what is that? Look at the triple S USA. From saturated to unsaturated, we know it's going to be elimination. Can you see? It's elimination reaction. That is the answer, guys. It's elimination reaction. So the type of reaction represented by reaction 2 is elimination. Don't forget the word reaction, right? You have to write it in full. Also here, question 4.1.1, you have to say substitution reaction. So the word reaction is very important. Now, that is 1 mark. Now, let's go to question 4.1.5, the IUPAC name of compound B. So question 4.1.5, we want the IUPAC name of compound B. Look at compound B, guys. We are moving from a haloalkane to an alkene. Look at your summary now. From a haloalkane to an alkene. Look at the arrow that goes to the bottom left. The arrow that goes bottom left, right? So look at that. It is elimination reaction because you are moving from the saturated to unsaturated. It is elimination, right? But what are we eliminating? We're eliminating the dehydrohalogenation. We're eliminating the hydrogen and the halogen atom. All right, we're eliminating 2 things here, the hydrogen and the halogen atom. Which halogen atom are we eliminating or removing? Remember, to eliminate is to remove. So the Br atom is the one that we're going to remove or eliminate, as well as the hydrogen atom, all right, to form an alkene. All right, simple like that, guys. Okay, guys, for us to form the IUPAC name of compound B here, we have to look at the fact that from a haloalkane to an alkene, we're going to remove the hydrogen and the halogen atom. All right, so we're going to remove the Br atom and the hydrogen atom. Look at this. This is what is going to happen. Look at what we're going to do here at the top. Look at the top part, right? This is question 4.1.5. This is my haloalkane that I'm having here. So guys, we're going to remove the bromine atom and the hydrogen atom. So in this case, it doesn't matter where we remove the hydrogen atom. It doesn't matter in this case, right? So this structural formula here in question 4.1.5 is actually this one here. So this is represented here, is the structural formula, okay? So we're going to remove the Br atom. So we're going to remove this guy, so I'm going to show it in blue. We're going to remove the bromine atom as well as the hydrogen atom. When we have removed that, they're going to bond, right? And what are going to form there? We're going to form an acid, all right, which is the hydrogen bromide. We're going to form the hydrogen bromide, which is an acid, right? But we know that immediately after removing the Br and the H atom, the hydrogen atom, we're going to form a double bond here. There's going to be a double bond, all right? Because we need to balance those carbon atoms, all right? We need to balance them. Remember, each carbon must be surrounded by 4 bonds. So we need to balance them after removing the bromine atom and the hydrogen atom. So it means, oh, okay, we need to remove the Br and the hydrogen. After removing them, we're going to form a double bond. That's what is going to happen there. And that is what is happening. Okay, so we can see that, oh, okay, after removing the Br, so let's remove these two. Okay, we're going to remove them now. Now we are removing them. We need to add a double bond there. Okay, so now it's balanced. This carbon, what is it having? 1, 2, 3, 4. Now it's having 4 bonds. Can you see that, guys? Now it's having 4 bonds. So what is the IUPAC name of this guy here? The guy that we have formed, this guy. What is the IUPAC name? IUPAC name is going to be 2-methylpropene. It is going to be 2-methylpropene. Why are we saying 2-methyl? Because remember, this is carbon number 1, this is carbon number 2, this is carbon number 3, and the methyl is in carbon number 2. So it's going to be 2-methyl, and because we're having 3 carbons here, 1, 2, 3, the longer chain has 3 carbons, and then the double bond is in carbon number 1. Okay, so that's why we're saying it's going to be 2-methylpropene. That is the IUPAC name. Now let's go to question 4.1.6. all right, the type of addition reaction represented by reaction 3. Now they want us to be specific, the type of addition reaction represented by reaction 3. Now let's go to reaction 3. Now reaction 3, we can see that we are moving from an alkene which is unsaturated to a haloalkane again. Remember, a haloalkane, adding the bromine water here, because when we add 2 bromine atoms, we know that bromine water, okay, is bromine water. So we are moving from unsaturated to saturated. Remember, this is haloalkane. This is a haloalkane. A haloalkane is saturated because it doesn't have a double bond. From unsaturated to saturated. Unsaturated, look at the triple SU USA. Unsaturated to saturated, we know is going to be addition. But now they are asking, what type of addition reaction is that? They want us to be specific. From an alkene, so we can see that from compound B to that compound there, C4H8Br2, they have added someone there. They have actually added, so it's plus Br2, okay, plus Br2. Every time when they add 2 bromine atoms, you must know that this is bromination, okay, or halogenation. So what type of addition reaction is that, guys? Look at this here. It is bromination or halogenation to form a haloalkane. Okay, guys, very important. Okay, this is bromine water, this is bromine water. Okay, of course I didn't include it here in the summary, but you should know it by heart. Okay, that an alkene can undergo or can react with bromine water to form that compound there. Okay, you must know it by heart. So therefore there it's a bromination or halogenation. So I'm going to write bromination there. So it is bromination. Very important. So that is a 1 mark there. Now let's go to question 4.1.7. Balance the equation for reaction 3 using the structural formula. Where is reaction 3? Oh, using the structural formula. So for this question here, I'm going to write it down here. This is question 4.1.7. We're going to answer it here, down here. Now they want the balanced equation for reaction 3 using the structural formula. Now the structural formula is different from the molecular formula. That's very important. If you write the molecular formula, then you'll get 0 or maybe 1 mark, okay? 0 or 1 mark. So where are we starting? Reaction 3 starts from an alkene, and we know the alkene. We have the alkene, all right? This is my alkene that I'm having here. We're starting with our alkene, and what are we adding? Remember, we're adding 2 Br atoms, and I cannot write Br2, okay? This is wrong. You can't write Br2. Br2 is a molecular formula. They want a structural formula, which means they want the Br to be bonded with the Br, okay? The Br must be bonded to the Br atom. That's how it's supposed to be. For us to break the bond of Br and Br, okay, for us to break this bond, we need the UV light, okay, which is the heat. We need the UV light, guys. We need the UV light to break this. So the reaction condition here is UV light. Okay, what are we going to form there? We're going to form a haloalkane, but this haloalkane is very special because it's going to have 2 bromine atoms. Okay, it changes the color. Remember, it changes to colorless. Okay, from being brown to colorless. So that's what we're going to form. That is my haloalkane. So the main reason, guys, for addition reaction, all right, remember reaction 3, they've said that reaction 3, according to the question 4.1.6, reaction 3, we have said that is addition reaction. But remember, to add that bromine atom, it means we're going to break the double bond. Okay, we're going to break the double bond. We're going to break the double bond. Okay, so it means, oh, the Br is going to be added. Br here is going to be added to carbon number 1, and it's also going to be added to carbon number 2. But for them to be added, we need to break this double bond here, the double bond of that alkene. Okay, the double bond of that alkene, we need to break it. That's what it means. Okay, which is the 2-methyl propene. That double bond, we need to break it, and then Br atom will go and bond to the first carbon there, and then the other Br atom is going to go and bond the second carbon. But it means that since it's addition, we're going to break the double bond. Okay, and then we're going to form that is what we're going to form, the Br in carbon number 1, and then the Br is in carbon number 2. All right, guys, that is very important. This is where we're going to end. Thank you very much for watching. Bye bye, and God bless.